You're welcome. We quickly want to look at continuation of our class on quadratic equation. So the last time we looked at quadratic equation and we were able to see how we can use factorization method in solving quadratic equation. So this time around today, we want to hmm, so we want to continue from there. We want to see uh, so now these are some of the things that we are going to look at today. Review of the Kahoot test. We had the Kahoot test last week. We also look at perfect squares and algebra. We look at application of perfect squares in algebra. Then we as well look at completing the square method of solving quadratic equation. So these are some of the things that we are going to look at today. Um, so we quickly need to review the Kahoot results that we did. Let me take us there. Um, some of the we're going to see some of the results of the Kahoot. Uh, okay, I think I need to stop sharing here. Take this here. Okay, so okay, so this is mm, let's see the podium to see the winners of the competition. So we have David Dosidi took the third position. Father on second position, and the fourth position goes to Gbenga. So that's just the result of it. So let's just see some of those things that we need. The players that we have there. I realize that some of you did it twice, which is not expected. So that is what you can see. The leaderboard, the performance. So we can see that these are most people answered seven correct questions. Seven questions correctly, seven eight. So these are some of the things. Now, the father answer is coming twice. Three guys coming twice. It's not good enough. So these are some of the results. So I will like you to some of the questions. Let's go and revise very well. I realize that there are some questions that these are the questions. Yes. So there are some of the questions that you kind of have challenges. Uh, yeah, these are the questions. You can just research them and then possibly go and look at the questions. Go and look at the questions. Okay. So if there's any challenge or this, if when you look at it again, you can just show it to the platform. Let's see how we can. I think there's another question after. Okay. Yeah, 4 y squared minus 9. So uh that is just some of the things that we need to look at the count. Let me see. Um, okay. Let's see. I'm thinking, do we have any question, any challenge here? Okay. So in case there's any challenge, I think part of everything we have done. Yeah. So if you sit back well, look at question number 2. You need to expand and bring 12 inside before you can be able to solve that question. You can't solve it directly like that. And question 10. Now we have 5x squared minus 8. We need to factorize it, bring out 5 first, then look at the last question, question 11, 4y squared minus 9. So let me just try to review these two questions. Then number 8, when you expand, just compare, compare. You see what your key is on this side of the question, right, or the right hand side of the question. I think I've mentioned that in the previous question. So let me go back to my class note. Okay, so I want to believe you can see it now. Okay, so let me just quickly solve those questions. I identified two questions. The first one is question of 5x squared, 5x squared minus 8. So what we just need to do here is question and identify question 10, question 11, that one is 4y squared minus 9. So what you just need to do here is what is common? 5 is common. 3 got 5. Then what you have the x squared minus 16. There is what we call difference of two squares. Difference of two squares. So when you see that this is a square, this one can also be expressed as a square. We all know that you can express 16 as a square, give us x squared minus 4 squared. So from there, anytime you have difference of two squares, you can see minus means difference of two squares. Then to factorize it, you take x minus 4. You can see I'm taking 1, x is power 1, 4 is power 1. Then x is power 1 plus 4. X minus 4, x plus 4. That's how you uh, factorize that. So you can do more examples from the table. For the number 11, we have 4y squared minus 9. You also look at it. Nothing is common. But we realize that all those numbers and data we have here, they are squares. See, look at 4. You can have it as 2 squared, y squared minus 3 squared, which is for 9. So what I just need to do here is I can see that 2 and y. I can bring them together by saying 2y all squared minus 3 squared. So just like what we applied here, we take 1, 2y minus 3, 2y plus 2. So that's just how we can do that. So I want you to take go to your question and solve as many questions as possible. Possibly before the end of this week, I can also send some other questions on it. So when we practice, we say this perception. Let's practice as many questions as possible. You don't have to limit yourself to what your teacher has taught you. So the next slide. Now we're going to look at perfect squares. So what do we mean by perfect squares? When we say perfect square, we say any number that can be expressed as a square of another integer. For example, uh, when the number can be expressed as the power of integer, as the square of an integer. So for example, I can express 1 as a square of an integer. So 1 is given as 1 square. So this 1 is a perfect square. I can also have the 4. 4 is given as 2 squares. This is square. 4 is a perfect square. 3, you also, I can also make another example like 9, which I can express as 3 square. So that is what we mean by perfect square. So it means 1 is a perfect square, 1 square is a perfect square, 4 is a perfect square, 2 square is a perfect square, let's say as 4, 9 is a perfect square, 3 square is also a perfect square. Now we can now go on and do so many examples. You can have 16, which is 4 squared. Now, in this case, let's bring in what we mean by algebra. Now I can just write 4 as an algebra. I can say that I'm hiding a particular number for you, and then let me say that number I'm hiding for you is y. Y. So you can just say y. Okay, I'm hiding, for example, 3 from 4 now. I'm going to rewrite 4, and I'm hiding 3 there. So I can have 3 plus 1 will give me 4. Sorry. So, but the y is what I'm hiding is 3. So 3 plus 1 will later give me 4. But I'm hiding, I just so that's why I'm using the letter y plus 1 squared. So in algebra, let me see what this will give us. So this when you expand. In our expansion, they have told us we are going to write it twice. We write twice. Then you dismantle one of the brackets, use it to multiply the other. You have y. When you dismantle this, I have y plus 1. I'm going to have plus 1 left here. I will also use the plus 1 to multiply. So with that, if I expand this, I should have y squared plus y plus y plus 1. And that should give me y squared plus 2y plus 1. So, directly now, anytime I want to expand something of this, so I can write directly. The form that is taken is just take y squared. We start it, then 1 square we end it. Then what will be at the middle? I just need to multiply 2 times y times 1 as 1. So it means my expansion of 4 is equal to my expansion of 4. And if you look at it, I said I was keeping 3. If I put 3 there as y, you realize that I should get what? I will get 16. Let's try that. I'm going to have 3 squared plus 2 times 3 plus 1. 3 squared will give me 9. 2 times 3 is 6 plus 1. That's 16. So just like I said, I was trying to hide 3. So I put it as y. So that that's it. I was able to get my 16 back as what? 3 plus 1 squared. That's 4 squared. So that's it. So I also have another example. I can have maybe y minus 2 squared. So I have this. I'm going to start with y squared. For the middle, I'll just multiply 2 times y times minus, that's minus y. Then minus 2 squared give me plus. So what we are just trying to say is that y plus 1 squared. So you say that y squared plus 2y plus 1 is a perfect square. Y minus 2 squared, which is saying that y squared minus 4y plus 4 just was a perfect square. I can also have so many examples. Example 7, I can also have the y plus 3 squared. What would this give me? Based on, as I told you the other time, yeah, you should have what? Y squared plus 2 times y times 3. That will be 2 times 3 is 6y plus 3 squared 9. And we also have some other examples like y minus possibly minus e squared. Let's see, what will it give us? That was what? Y squared by 2 times y times 8 times minus 8. 2 times minus 8 gives you minus 16. Multiply by y, that will be minus 16y. Minus 8 squared will give you 4. So you can go on and on and do so many examples. But what we just want to bring out here is how can we write perfect squares in algebra. And at the same time, what we see the relationship between numbers that we have, letters that we have. Now look at it. Look at the first one, y plus 1 square. You realize that we have relationship between all these terms. For example, I'll pick the second and the third term. So if you look at the second term, this is 2y. You realize that the third term, you can derive the third term from the second term. How? Just come to the second term, look for the coefficient of y or coefficient of the variable. The variable here is y. The coefficient of y here is the number beside y. That's plus. When you look at the plus 2, look at the plus 2, divide it by 2. When you divide it by 2, you realize that we have what 1. Square the 1 to give us 1. Do the same thing for this. Minus 4. Divide it by 2. You realize that we are going to get minus. Even the minus you got is the 1 here. Square the minus 2, you have 4. This is what you have. Same thing here. If you come here, half of the coefficient of y here, half of 6 is what 3. You realize that the 3 that you have here. Now, the 3 square it, you have 9. Half of minus 16 is what minus 8. This is minus 6. Now, square that minus 6, you have 6. So, that is what you want us to get from this. That principle will assist us in applying the perfect square in solving quadratic equations. So, as many as examples we can go and learn and do so many examples. For example, let's have an example of so you can also try on your own, expand this and be sure that it's going to give you this. Expand this and be sure that it's going to give you this. So that is it. So you can also go on your own to expand x minus 10 squared. Let's see what it will give us. Alright, so let's go to the next slide. So we want to apply what we have the perfect square. Now look at this question. The what must be added to the following to make it a perfect square. So in this case, this is a square plus 8a. And I told you to get the next number that you have here, it means you must find half of this and square it. Half of 8 plus 8 is what? Plus 4. Square plus 4 plus 4 square. And that will give us what? 16. So it means it is 16 that must be added to a square plus 8 to make it a perfect square. 16. And at the same time, you also remember that if you want to simplify that, if you want to factorize that, it will just be that you take a here and take plus 4. A plus 4 squared. We are expressing as a perfect square. Give us a plus 4 squared. I hope you have not forgotten that. Let's go back to this. So you can see here that this one can also be said to be y plus half of it. This one can be said to be what? Y plus half of it. So that's what I've tried to establish here. Now let's move on. So for this also we do it in the same manner. X squared plus 5x. So what do we do? Look for half of 5. What is half of 5? That would be 5 over squared. Just pick that number half. Multiply by whatever that you have there. Half multiplied by 5 over 1. That would be 5 over squared. So by the time you look for that, 5 squared is 25. 2 squared is 4. That would be 25 over 4. And if you need to express the how to factorize it like that, just take 1 here, take 1 here. This is plus and square them. So this is x plus 5 over everything squared. So that is that. Let's look at the next one. Next one here, we have n squared minus n. So you see that indirectly we have a coefficient of what? 1. Yes, 1n. What must you add? You look for half of 1. Half times 1 to give us 1 over 2. So we have minus that is minus 1 over 2 squared minus 1 over 2 squared. So with that, minus 1 over 2 squared, if you look for that out, we are going to have what? Minus 1 square will give us 1, 2 square will give us 4. That was 1 over 4. This is 1 over 4 that will be added to n square minus n to make it a perfect square. Now, so let's see, if you want to factorize, what do we have? If you take 1 here, that's n. You take, that's, you have to provide, you take n, then you take this, so that's minus half. That should give us 4. So the same way you do all this, look at this. This is minus 1 over 1 over 3. You just need to take it to an improper fraction. That would be 1 times 3, 3 plus 1, 4. That would be 4 over 3. So if you did half of it, this is half of 4 over 3. Half, what's that? 4 over 3. 2 here, 1, 2 here. Which means what you are adding is minus 2 over 3 squared. Minus 2 over 3 squared. That's what you are adding. So what would that give us? Minus 2 square will give us 4, 3 square will give us 9. That would be 4 over 9. And if you need to express it as a factorize it, you take k and you take what? Minus 2 over 3. You square it together. You square it together, it will give you all this. So let's look at the okay. Let me just take 1 out of 6 and 7 to check. Now, m squared minus 8m. What do you do? Half of coefficient of m. You cancel. You don't need m. You have not been writing the letter. But in this case now you have more than one letter. So the major variable is what m. So what's the coefficient of m? What is stopping m there? That's what minus 8m. So that's what we're going to figure out. Half of minus 8m. Half of minus 8m. That was what? 4m minus 4m. Square it give us what? When you do that, minus 4 squared is m squared. That's what must be added to make it a sorry, minus 4a. The coefficient of 8n, 8n is what? Minus 8n equal to the n. Sorry for that. So then this is n, this is n squared. So that is that one. No, this is n squared. And if you must factorize, means we have m minus 4a everything squared. So that is that. We quickly move to the last part, which is how do we now apply this in solving for that equation. Now that is what's called complete the square method. What do we do? Let's see these two questions I have here. I'm going to solve like one or two, and I will leave you to solve the rest. Now look at this q squared. So number 1 q squared plus 10q plus 22 equal to 0. So what you just do is to write it in the way that we have written in the last one. Take minus plus 22 away so that we have q squared plus 10q equals to minus 22. You now ask yourself, what can I add to this to make it a perfect square? I want to make this a perfect square. What do I add to it? So from what we did in the last example, you add what? Half of coefficient of what? 10, coefficient of q. So you add half of uh coefficient half of 10. Now, this is an equation. Whatever you are doing to this side, you must do to the other side. You have to make it just there. That's how mathematics is. You have to be just. You can't just add to one side and leave. You can't just add to one side and then leave the other side. You must balance it up. So how do we do that? Don't forget this from the last example. Check your notes. Realize that we add half of 10. So what do we add? We have q squared plus 10q. Now, half of 10 is what? 5. That's plus 5 squared. So whatever you have added to this side, you must add to the other side. Minus 22 plus 5 squared. Now, I also told us in the last one, the last slide, that in this case now, when you now want to express this, when you want to factorize this, you don't need to disturb yourself, but just take one of this cube, take one of this plus 5, square it. By the time you expand this, you are going to get this now. So just come to, you don't bother yourself about what the middle one. You have used the middle one already, you have used it to get this 5. So when you now want to factorize, just pick from square, pick from q, pick from plus 5 square. So you have q plus 5 square equals minus 22 plus 5 square will give us what? 25. So from there, what do? We have q plus 5 squared equals minus 20 plus 25 to give us 3. So from what we did last week, when you have something of this nature, what do? You find square root of both sides. When you square root both sides, you have q plus 5 equals plus or minus square root of 6. So what do? Then you take this one to the other side. We have q equals minus 5 plus or minus root 6. So so that's where I'm going to hit. I want to believe that you can continue from here. Just find the source of 3 and continue from here. Yes, let me pick, for example, 3 also. So that is what we mean by complete the square method of solving for classification. We have z squared minus 5z plus 6. So also take equals to 0. What do? Let's express it the same way we have been expressing others in the last slide. Just take minus plus 6 away. And let's see what we have. Z squared minus 5z equals to minus 6. Now, what must be added to this to make it a perfect square? Let's see, what can we add? So it means you add half of the quotient of z. So we have z squared minus 5z. Half of 5, just come in. Half multiplied by minus 5. Give you minus 5 over 2. So that will be plus minus 5 over 2. Then square it. Like I said, you have to be taught. Whatever you do to this side, you must do to the other side to balance it up. So this that we have added, I want to believe you all know how we got minus 5 over 2. That's half of 5, half of minus 5. Minus 5 happens to be the quotient of z. Half of minus 5 divided by 2. Square it. So plus minus 5 over 2 squared. So from there, I said when you want to factorize, you need to stop yourself. Just take one of the two squares. So Z is one of the two squares. And 5 over 2 is also one of the two squares, the other one. So bring them together and square. When you square this, when you expand it, it will give you the same thing as equals to minus 6 plus 25. 5 square, 5 square give us 25, 2 square give us 4. So from there we have Z minus 5 over 2 squared be equal to, find the LCM here. I'm going to have minus 24 plus 25 divided by 4. So we have Z minus 5 over 2. The square root both sides. Okay, yeah. Let me see. So that would be 2 minus 24 plus 25 give us 1 over 4. So just like we did last week, we need to finish this up. Square root both sides. When you square root both sides, what do we have? Sorry. So we have Z minus 5 over 2 is equal to plus or minus square root of 1 over 4. So Z can now give us minus 5 over 2, we take it to the other side, out 5 over 2. Plus or minus square root of 1 is 1, square root of 4 is 2. So find the LCM 2, we have 5 plus or minus 1. So hence you can see that Z equals to 5 plus 1 over 2 or 5 minus 1 over 2. 5 plus 1 is 6, 6 over 2 give us 3. 5 minus 1 is 4, 4 over 2 will also give us what? 2. So that is the solution to that. So the answer is 3 or 2. So I don't want to spend more time. I want to stop here. So I have some other questions for you to see. You can also go over this. Then I also have an assignment for you. So for the assignment, you have okay. For the assignment, just go to your new general mathematics. Uh, sorry, new general mathematics. Okay. That's exercise book 2, exercise 3D. You solve the question number 10, number 14, number 16, and 24. Then for the other one, I'll be assigned 3C, numbers 6, 10, 14, 20, and 24. So that is how we are going to get to this class. Thank you very much. Sorry that we could not have the last class. I was actually on a journey and the flight for today. So very sorry about that. Surely such hope such will not happen again. Uh, so thank you very much. We're going to head the class now. Have a nice time. And make sure you do your assignment. The one you have submitted, I will go over it. The majority of you submitted late, however, I will go over it and